Simple examples of batteries with resistors. If you have a single resistor here connected to a battery, 60 ohms, 12 volts, your go-to formula for all of these is V equals IR. So you have 12 volts equals current times 60 ohms, or 0.2 amperes is the current. That's pretty much the story. If you need to calculate the power, it's IV, which would be 0.2 amps times 12 volts, which would be 2.4 watts. What if you have more than one resistor? These two are connected in series, end to end. They're all like beads on a string. So the total equivalent resistance is just R1 plus R2. So 60 plus 30 is 90 ohms. So performing V equals IR, now which V, which I, and which R are we talking about? The only V we know is the V of the battery. So we always start there. The current we get is going to be the current running through the battery. And the R is the equivalent resistance of the circuit. So 12 volts equals current through the battery times 90 ohms. So 12 volts over 90 ohms is 0.133 amperes. Now, because this is a simple series circuit, there's only one current. The current here is the current here is the current here is the current here. So you could use V equals IR again to figure out, say, what was the voltage drop across this resistor, because you know I and R. So 0.133 times 60 is 8 volts. So you end up with an 8 volt drop from there to there. And so the remaining 4 volts drop there to there. How about another one? If we put the resistors in parallel and 12 volts, 60 ohms, 30 ohms, if you want the equivalent resistance, it's because these are in parallel, 1 over Req is 1 over 60 ohms plus 1 over 30 ohms. So that's 1 over 60 plus 2 over 60 is 3 over 60 ohms, which means that Req is 20 ohms. V equals IR, with the V battery, current battery Req, tells us that 12 volts equals current through the battery, 20 ohms. So 12 over 20 is 0.6 amps is the current from the battery. Now we have more than one current because we have branches in the circuit. If you're confused about the branches, look for the junctions. Junctions are any place 3 or more wires come together, like a T. So this is a junction and this is a junction. A current starts at a junction and goes until the next junction. So the current through the battery, the 0.6 amps, runs through that wire. But then the 0.6 amps has to split. Some of the current goes this way and some of it goes this way. How much goes which way? Well, we can use V equals IR again, because we actually know that 12 volts is directly across the 60. So just as in this example, 12 volts across the 60 gave us 0.2 amps. So we know that there are 0.2 amps running that way. Starts at junction, ends at junction. And finally, the remainder of the current is 0.4 amps. I could have gotten that from V equals IR, but I got it just from subtraction. So that's how you handle two resistors in parallel.